In this video, we will implement acceleration and deacceleration to make our movement a bit more smooth, as well as we are going to refactor our tank controller script into tank controller, tank mover, and turret, and aim turret, so that we have separate scripts to do each separate thing, so we have more object-oriented architecture of our movement system. This video is part of the series of videos about creating a 2D top-down tank game. We will explore different features of this game, each as a standalone video. Hi, I'm Peter, and welcome to Sunny Valley Studio Tutorials. In the previous video, we have implemented tank movement. We can move our turret using our mouse, and we can use our body of the tank using the arrow keys. Now, there is an issue with this system because if we press forward direction, the tank will keep on moving and we do not have any control over it, because to get our player input, we are using input.getAxis, which simulates the values between -1 and 1 depending on the sensitivity that we set. We would like to use another function. This would be getInputRaw to get the values between -1, 0 and 1 instead of the range and the sensitivity, and instead we would like to use acceleration and deacceleration, so maybe a heavier tank would move a bit slower and light tank would move a bit faster and accelerate a bit faster. Another thing that I would like to improve is the tank controller script. Currently, the tank controller script is responsible for handling the input from the player, but as well it is responsible for actually moving the rigid body 2D and setting the speed and rotation and getting the information about the transform of the turret parent, which allows us to rotate our turret around. And this is too much responsibility for a single script, so we are going to refactor this code as well. So let's refactor this code and let's implement acceleration and deacceleration to handle our tank body movement. We are back in Unity. I would like to create 3 scripts that will be responsible for handling the tank shooting, the turret movement, and the tank movement separately. So let me create a new C# script, and I'm going to create tank mover. Next, I will create a new script, and I will call it aim turret. Okay, and I will create next script, and I will call it turret. Okay, great. We have some error, doesn't matter. For now, I would like to open up our player, which is our tank, and our tank is the avatar containing the sprites for our tank base and containing the parent, which allows us to rotate our turret around our chassis, and the turret itself, which is representing the sprite of our turret. Now, since tank base is the body of our tank, I would like to drag our tank mover script onto the body. Now the tank turret parent is responsible for rotating the turret, so I would like to have the aim turret on this object, and the tank turret itself will be responsible for shooting the bullets, so I will assign the turret script onto this object. Now all we need to do is to extract some parts of the code from our tank controller into our separate scripts. So I will open our tank controller and I will open our tank mover script. Okay. First of all, I would like to move the rigid body 2D reference from our tank controller to our tank mover. Let me delete the update and start methods. We will create them when we need them. Now, since we have some issues with our tank controller, I will get the reference for the rigid body inside our tank mover. And since tank mover is a child of our tank parent game object, and the tank parent game object on which the tank controller resides has the rigid body, we need to search for the rigid body to be equal to get component in parent. And now we are going to get the reference to the correct rigid body. Now we have our max speed for the tank and max rotation speed for our tank. So we are going to move those 2 variables into our tank mover script as well. Great. Now, when we are calling the fixed update, we are referencing the rigid body 2D as well. So we are going to simply move the whole fixed update method from our tank controller to our tank mover, and this will be responsible for performing the movement. Now all we need to have here is the movement vector. So we are going to move the movement vector from our tank controller again to our tank mover script, and we will need to populate the value of it. So we are going to create public void, and let's call this method move. And I want to take an argument of type vector2, and this will be the movement vector. Okay, and when we have this value, we're going to assign this dot movement vector equals the movement vector that we get as the argument of this method. So now the last issue that we have is in our tank controller, and what we want to do is we want to get the reference to the tank mover in our tank controller. So let's create public tank mover, let's call it tank mover. Okay, and since we are not sure if the user will assign it, we are going to call awake, and we are going to check if tank mover equals null. We are going to call tank mover equals get component in children, and we are going to call this get component, so single component in children, and we are going to pass the tank mover type of component. And now we will simply call this tank mover to handle the movement, so tank mover dot move, and we are going to pass it the movement vector like this. Okay, let's save the script. Ctrl+Shift+S to save all the scripts. Let's go back to Unity. Okay, so just to recall, our player has the player input script on it with Unity events that pass the vectors that we passed from the player input, so the arrows and mouse input. We are passing it to our tank controller. For example, tank controller handle move body is receiving a vector2 that is the input from the arrow keys from our player. Now the tank controller will get the tank mover, and it will pass the information about the movement to this tank movement script. Let's press play, it should all work now. And we are going to have our tank, and it still can move, but it is moving pretty slowly because I didn't set correct values for it. So let me go to our tank base, and we have our max speed, let's set it to 70, and rotation speed to 200. Let's press play, and now we should be able to move a bit better. Let's stop it. Now the second script that we have created was the turret, and the third one was the aim turret. So I will open the aim turret and tank controller to implement those methods from our tank controller into our aim turret class. Okay, so our aim turret should be responsible for moving our turret, so rotating it basically. We have our handle turret movement inside our tank controller, and it has many methods that are responsible for calculating the angle and rotating our turret parent transform that we get the reference here in our tank controller. We can delete this, we can move our public float turret rotation speed to our aim turret, and we are left with very little code in our turret controller. Now, to handle our turret movement, we will need to implement a new method in our aim turret. So let's create a public void aim. We are going to take vector2 as the input, let's call it input pointer, or maybe input pointer position. And we are going to simply get the reference to our aim turret inside our tank controller. So let's create public aim turret, and let's call it aim turret. And what we will want to do is copy the same in the awake section, the same code, and check if the aim turret is equal to null. If it is, we are going to find it inside our children. Let's find aim turret type of object. And now all we need to do is inside our handle turret movement, we are going to call aim turret.aim, and we are going to pass the pointer position to it. Now the remaining code from our handle turret movement we are going to extract and place in the aim of our aim turret class. Now as you can see, we are getting the pointer position. Now it is input pointer position. So let's replace this invalid name with the valid one. And now we do not have turret parent because the transform of the aim turret is the turret parent transform. So let's call transform.position. And now you can see that this makes the code much more easy to read because we know that we are referencing this transform of this object. We are calling the aim. This is a very short script, so you can easily read what is going on here. And now our turret controller also got shorter. Again, Ctrl+Shift+S to save all the scripts, and let's go back to Unity. Great. Let's press play, and let's see if we can still use our turret, and we can move our tank. That is great. Now, last thing that I wanted to modify was how we perform shooting. So currently, if we press play, we will see in our console the shooting message. We will implement shooting in the next video. For now, I want to move this shooting debug.log statement to our turret class. So I'm going to open turret class and the tank controller, and we are going to refactor the code to have this all in separate objects. Okay, we are in Visual Studio. I have the tank controller and our turret class. I'm going to remove the start and update from our turret class. Again, we will need to create a new method inside our turret class. So let's create public void shoot. This will not take any arguments, and we are going to simply cut out this debug.log statement to the shoot method. And now we will need to get the reference to our turret class from our tank controller. And this is an interesting thing that we have now, that if we have multiple turrets on our tank, we can access all of them and make all of them shoot at once. We do not care if we have one or multiple turrets. So this is the power of object-oriented programming, that now if we have split this class to the turret and the tank controller, now we can get a reference to a list of turret classes. So actually what we can do is create a simply public list of type turret. Okay, let's call it turrets. Now if we call in our awake if turrets equals null or turrets.count is equal to 0, we can call turrets equals get components in children with s, but this method returns a component array. So instead of using a list, we are going to use simply an array to have an easier time getting those values. And we cannot really use count, we need to call length here. Now we can get the type of turret, and we have all the access to all the turrets attached to our tank. So now what we can do is when we have our handle shoot event callback, we can call for each tab to create this from a snippet var turret in turrets, and we can call our turret dot shoot. And now we are calling shoot on all the turrets attached to this tank. So let's save it. Let's go back to Unity. Okay. Now, as you can see, we have our tank parent, which is currently rotated. Let's set the Z value to be 0. And let's duplicate the tank turret and move it to the right. And let's move the tank turret without a number to the left. So now that if we rotate our tank parent, we have 2 turrets. And we didn't do anything with the code, but now if we press play, we should see 2 shooting debug.log statements, meaning that we are controlling both turrets with a single click, and we can add more turrets to our tank, and they will all work with our mouse click event. So last thing that I wanted to add is to add a better movement, since right now, as I have said, if we let go of moving forward, we are getting a bit of a forward movement still. So let's stop the game, and we are going to edit the player input script. Okay, we are here in the player input script that we have created previously, and inside our get body movement, we are calling get axis. Instead, I would like to call get axis raw and get axis raw, which will yield a value between -1, 0, or 1. So now what we can do is we can go back to Unity, and if we press play, our movement will look a bit more stiff. If we let go, the tank will stop immediately. This is not desirable because we want to have some kind of acceleration and deacceleration so that the tank movement feels more fun. So let's stop it and let's open up our tank mover script. We will need to modify the script a bit, so I'm going to add a couple of fields to this class. Okay, we have acceleration, which will be used to accelerate, deacceleration, which will be used to slow down our movement, current speed, which will be the current speed of the movement, and current forward direction, which will be either 1 or -1, depending on which arrow was last pressed when we have performed movement. Now, to use the fixed update, we will need to modify the velocity settings here. We do not want to use movement vector y value for the setting, and we will need to use, instead of max speed, we will use current speed. Now the issue is that the current speed is always 0, so we will need to calculate it based on the acceleration and deacceleration. So in our move method, we will create calculate speed method, and we are going to pass to it movement vector. Now to create this method, you can right click, quick actions, and generate this method, and we will want to check what is the value of our movement vector.y. So we are going to create if statement. If our movement vector.y is greater than 0, we are going to set our current forward direction equals 1. Else, if our movement vector.y is less than 0, we are going to set the current forward direction equals 0, so that if we stop pressing the arrow key, so the up arrow key or down arrow key, our tank will keep on moving in this direction until it stops. Okay, so this is it. We have an if-else statement. If our math.abs of the movement vector.y is greater than 0, we want to accelerate. So if we are pressing up or down key, we want to accelerate, else we want to deaccelerate. Now, we want to also clamp the value that we have to be between 0 and max speed, so that we do not get the minus value or we do not exceed the max speed value. And this is the calculation of our current speed. So either we are accelerating, we are adding to the current speed, or deaccelerating, we are subtracting from this current speed. And we are using this current speed in the fixed update to drive our tank, but we are not using the current forward direction anywhere. So we want to use it for the calculation of the velocity. So let's calculate the current speed times the current forward direction to get the correct direction of movement. And this should be it. Let's save it, Ctrl S, and let's go back to Unity. Great! So now in our tank base, we should have those values of max speed, rotation speed, acceleration, deacceleration, current speed, and current forward direction. I want to set those to private, but for now let's test if this works. And now we should see that our tank is accelerating and deaccelerating, and we can change those speeds. So for example, we can change the deacceleration to 90, and it should much more quickly, and this should feel a bit more fun to play. So again, in the next video, we are going to take care of the turret shooting a bullet in the direction it is facing, and in the future episode, we are going to extract all those parameters for our tank scripts, so all the values of all the data into scriptable objects, so that we can keep the scripts to have only the state of the script and the behaviors, while the data will be passed to it through the tank controller by the scriptable object. If you want to support me, please take a look at my Patreon website, check out my Udemy course about creating a 2D top-down shooter using the URP and Unity 2020. There will be a link with a discount in the description if you are interested. Okay, great, thank you for watching, leave a like, subscribe, and I will see you in the next episode of this series. Take care!